All right. What's the probability you flip a coin and roll a six-sided die? So we're doing two things, and we get heads and a number 3 or greater. Right? So whenever you do and probabilities, you just multiply. So probability of heads is 1/2. Probability of 3 or greater is 4 out of 6. That's 4 out of 12, which is 1/3. All right, you win 2 raffles from your school. Probability of winning the first one was 7%. The probability of winning the second was 14%. If they're independent, what's the probability you win both? First probability times second probability equals the probability of both happening. So okay. Zoom out a little bit. About 1% of the U.S. population is Chinese American. Suppose 2% of the population visits China in a given year. Assuming these are independent, what's the probability that a randomly selected student or person is Chinese American and has visited China in the last year? So, this is the probability they're Chinese American. This is the probability they visited China. If we assume they're independent, the probability of both happening is this probability times this probability. So I think I know what this is, but let me double check. Okay, you might have gotten something like this in your calculator, and if you write that, that's not incorrect. Okay, I'll accept either one there. Okay, continuing from this in this thought process, is it likely that these two things are independent? Being Chinese American and visiting China. No, it's not likely that these two things are independent. So the probability of visiting China is likely higher for Chinese Americans. May not even be much higher, but I would be very surprised if it wasn't just like a little bit higher. Based on your answer to the previous question, is the probability of a person going to China and being Chinese American higher or lower or the same as what you previously said? Well, basically, this number is wrong. Okay, we expect this number to be higher for Chinese Americans than it is for the rest of the population. So if we make this number bigger, this number is going to be bigger. So we expect it to be higher. Because if we change 2% to a higher number, the product will be larger. All right. There are 12 eggs in a carton. 3 have been broken and are now bad. While making breakfast, you blindly grab 2 eggs from the carton. What is the probability both eggs you've grabbed are good? So we need to do 2 things. We need to grab a good egg, and then we need to grab another good egg. And since we're doing the probability of both of those things happening, we are multiplying. The probability you grab a good egg is 9 out of 12. But if you reach back in, now we only have 8 good eggs, and there's 11 eggs left. So it's the product of these two. So we get 6 out of 11, or that's about 0.545. What's the probability you blindly grab 2 bad eggs? Well, probability it's bad is 3 out of 12. We have 3 bad eggs. We've got 12 eggs. Okay. And then you grab another one out. And so that would be 2 bad eggs left. And then 11 eggs left. So let's see what this is. 3 times 2 divided by. I got 1 out of 22, which is approximately 0.045. All right, which is more secure, a password with 10 lowercase letters or a password with 6 lower or uppercase letters? And we're going to explain with calculations shown. So we could do a password with 10 random lowercase letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or we could do a password with 6 characters, but these could be lower or uppercase. So there are, if we do just lowercase, that's 26 possibilities, and 26 and 26, etc. That's 26 to the 10th. All right, that's going to be a big number in case you were wondering. Here, it's lower or upper, so it could be 52, and we're doing this multiplied 6 times, so it's 52 to the 6th. So let's see what we get. 26 to the 10th. We get this, which remember, this is just scientific notation. 1.4 times 10 to the 14th. This is 1.97, so basically about 2.0 times 10 to the 10th. So which one's bigger? This is more options, so this is more secure. So the answer would be the 10 lowercase, because there's more possibilities. Which I probably just misspelled. But anyhow, good luck on your test tomorrow. I'll see you then.